Alright everybody, welcome back. In this video we're going to be talking about information from section 4 of unit 3 of AP Calculus, differentiating inverse trigonometric functions. First things first, in the work that we're going to do today, it is important for us to know some of these trig identities. Definitely the first one. The second one we'll use. The third one, because of my choice of rules for us to develop, we're not necessarily going to use that one. But being real honest with you, I will tell you that I really only ever remember this identity, and then I develop the other two if I need them. In order to get this identity right here, I just take this and divide by cosine squared of x, and that generates that identity. And if I want this identity right here, I just go ahead and I divide by sine squared of x. That gives me this identity right here. So I really only remember the first one. But if you remember all of these, good for you. They do come in handy at times. All right. Now, I'm going to kind of work backwards from how I usually do things here. Instead of proposing that we find a rule and then finding it, I'm going to start by telling you the rules, and then we're going to develop them. So here's the list of all the inverse trigonometric derivative rules. Okay, the derivative of the arc sine is 1 over the square root of 1 minus u squared. Of course, I did this with u, a differentiable function of x, and all of these du dx's are just the chain rule built in to our derivative rule. Now that we know the chain rule, we have these du dx's built in as the chain rule. So, if you're working from these rules, it's enough for you to remember that it's this, and then use the chain rule. But you should also notice some similarities between our formulas here for the various derivatives. The derivative of the arc sine and the derivative of the arc cosine are the same, except they differ by a negative sign. And the derivative of the arc tangent and the derivative of the arc cotangent, same exact thing, except they differ by a negative sign. And again, for the derivative of the arc secant and the derivative of the arc cosecant, same exact formula, except they differ by a negative sign. Okay, and you'll notice that as we go down here, all the ones with the negatives in them are the cofunctions, whereas the primary functions, the non-cofunctions, don't have that negative sign in them. All right. So in this lesson, this video and following videos, as we develop these rules and do examples, we're going to develop the rules for the arc sine. And then just know, if you develop the rule for the arc sine, the process for developing the rule of the arc cosine is pretty much exactly the same. With some very minor differences. When we develop the rule for the arc tangent, that's pretty much the same as the way we develop the rule for the arc cotangent. And again, same thing, if we develop the arc secant, it's pretty much the same as the development for the arc cosecant. And so we're going to actually develop rules 1, 3, and 5 here, the rule for arc sine, arc tangent, and arc secant. All right, so let's go ahead and start developing these rules. We'll start with developing the rule for the arc sine of u, where u is a differentiable function of x. And where we're going to start is we're going to use a lot of stuff that we learned a couple of sections ago with implicit differentiation. We're going to say, okay, let's let y be the arc sine of u. And if y is equal to the arc sine of u, that means I can take the sine of both sides of this equation and transform it into sine of y is equal to u. Okay, now this is something that I already know the derivative rules for sine, and I already know for u, so I can take the derivative of this with respect to x and see what happens. The derivative of sine of y, I take the derivative of the outside, leaving the inside the same, times dy dx. And here I take the derivative of u, there's my du dx. Okay, where do I go from here? Well, I'm trying to come up with a rule for the derivative of the arc sine of u, and since y is the arc sine of u, I'm trying to solve this for dy dx. So I'm going to go ahead and multiply both sides by 1 over cosine. That gives us dy dx equals 1 over cosine of y times du dx. Okay, now, what I want to do at this point, I want this derivative rule right here, I want this rule to contain nothing but u's, because this y was really a dummy variable that I introduced. We're finding a rule for the arc sine of u, so it makes sense for us to have our derivative rule just be in terms of u, of some function of u times du dx. So I need to figure out how to turn this 1 over cosine of y into an expression containing u. And it starts with that trig identity that I mentioned at the very top of today's video. You know, sine squared of y plus cosine squared of y is equal to 1. And if I solve this for cosine of y, I get that cosine of y is equal to plus or minus the square root of 1 minus sine squared of y. Okay. Now, we need to decide, do we use the plus sign or do we use the minus sign? And here's how we make that decision. It's all based off of the domains of these functions. Okay, the domain of the arcsine function is, let's see, it's going to be 2 of these quadrants. Which 2 quadrants is the arcsine defined? And it is defined in quadrants 1 and 4. Okay, that's where the arcsine's domain is defined. Now, what can we say about the cosine in these 2 quadrants? If you answered that it's always positive, that's exactly what we were looking for. In those 2 quadrants, the cosine is always positive. So I can eliminate the negative branch of this. And I know that in this scenario, cosine of y is equal to just the positive square root of 1 minus sine squared of y. So I can replace this cosine of y in my derivative rule with the square root of 1 minus sine squared of y. Okay, I still don't have just u's in here, and now I need to go back to my original, or this line right here. I know that u is equal to sine of y, and so I can replace sine squared of y with u squared. And so this ends up simplifying to dy dx equals 1 over square root of 1 minus u squared du dx. And there's our derivative rule. You know, I think back to when I took AP Calculus back in the Stone Age, back in the 80s, and I can remember my AP Calculus teacher just kind of gave us all these inverse trig derivative rules, and I was like, I have no idea where any of those came from. And he never really showed us. He was just kind of like, hey, keep an index card and keep these handy so that you have them, you know, and hopefully you can memorize them. And I never had any idea where they came from. And as I started teaching the class, I was like, okay, I got to make sure that I talk to my students about where these rules come from, you know, just in case. And like I said, the development for the rule for the derivative of the arc cosine is almost identical to this one. And it ends up just differing by a sign in the end. You know, we would start with y equals arc cosine of u. We'd end up with cosine of y equals u. We'd take the derivative of that. We'd have to make a replacement. We'd reason based off of the domain of the arc cosine, which branch of the radical we would need, and we'd end up in a very similar location. Okay? Of the 3 rules that we're going to develop in this unit, that's the middle one. It's not the easiest one and it's not the hardest one. Let's go on to the next page. We'll do the easiest one next. Developing the derivative for arctangent of u. Okay, so again, we're going to handle this using the same kind of basic idea. We're going to let y be equal to the arctangent of u, and we're going to take the tangent of both sides. And then we take the derivative of both sides using implicit differentiation. The derivative of tangent of y is going to be secant squared of y dy dx. And the derivative of u is going to be du dx, since we're taking the derivative with respect to x. Again, just like I did last time, I'm going to multiply both sides by the reciprocal of what's next to my dy dx. So this turns into 1 over secant squared of y times du dx. Now, I want to replace that with an expression containing u. I know that u is equal to tangent of y, so I'm looking for a connection between tangent and secant squared. Well, one of those trig identities that we talked about at the top of this video is that tangent squared of y plus 1 is equal to secant squared of y. And so, this works out really nice. I can just replace this secant squared y. I don't really have to think about anything like I did in the last example. I'm just going to replace secant squared of y with tangent squared of y plus 1. And then, since tangent of y is equal to u, I'm going to turn this tangent squared of y into u squared. So I get dy dx is equal to 1 over u squared plus 1 times du dx, which of course, if you recognize the commutative property of addition, you know that this is the same thing as 1 over 1 plus u squared du dx, which is our rule that we have. Okay, looking at my time here, I don't have enough time on this video to do the rule for arc secant, but that's where we're going to go next. In our next video, we're going to develop the rule for the arc secant, and then we'll go ahead and do some example problems using these derivative rules in context. Okay, see you then for video 2 on this section. Have a great rest of your day, and enjoy yourself. Until next time.